way too little time in your presentation, I have to say, because it was so interesting and intriguing, and there's so many options and challenges with data modeling and relationships and everything. There's so many mistakes you can do. So I'm really looking forward to this presentation.
Me too, and thank you so much, Dan, for doing this with us. And welcome everyone again to Tableau Sandbox. And here's our group of mentees. Most of them are here, and I hope none of them misses it. If you're missing it, then you can probably catch the recordings. Today we have Dan, who is a senior solutions architect at EPAM, BI team leader, and a Tableau ambassador for the last 4 to 5 years, and he will be continuing as well. And he has around 30 years of experience in business intelligence, data warehousing, OLAP, and analytical systems. So I would stop here and I would give the stage to Dan to talk and take us through this interactive session and interesting session on advanced data modeling. Thank you so much, Dan, again, for doing this with us.
Okay, thank you for inviting me. I'll just get the presentation up and start sharing my screen. Just a second. Okay, can you see my screen?
Yes.
And just a quick question for you, Dan. Do you want to have questions like as we go along in the chat, or do you want to save it for the end?
I think we can have questions as we go along. Let's start and see how many questions there are. So basically, I'm using my presentation from DataFrame Europe, which was I had to go through it really fast there, no questions and answers, because I had only 30 minutes, and of course, I've made a few changes. I've added some more explanations and demos, so we'll see everything along the way. So the initial title was Tableau Multi-Fact Models, Insights, Issues, and Fixes. We'll dwell very little on the issues and fixes. We want to talk mostly about the insights and how to use the multi-fact models. A bit about me. I'm a BI team leader at Naya Technologies here in Israel. I've been here for 12 years. Naya is a subsidiary of EPAM Systems, which is an American professional services company. So technically, I'm also a senior solution architect there.
Just a quick note, Dan, we can see that your Google Meet window, so we can see ourselves. Don't leave the meeting, please.
I don't know how to make it smaller.
Do you only have one screen, or is it?
Yeah, I have only one screen.
Okay. Yeah, just put it in the corner. Put the baby in the corner.
Yeah, just put it down here at the moment. Interesting. It shouldn't be showing it, but okay. I don't know. Okay, so by my background, as Prasan told you, and it's true, I've been working in BI for 30 years. I've been working with Tableau for more than 10 years. I've consulted with over 100 different Tableau customers, and that's where most of my my experience comes from. I'm a 4th year Tableau community ambassador. 3 years it was forums ambassador. Now it's all bunched up together. So I'm just a regular ambassador nowadays. Married, 4 children, and my other hobby apart from Tableau is orienteering. If you've never heard of orienteering, look it up. It's a really, really nice sport. And you can find me on these links. That's my LinkedIn profile, my Tableau public, and my blog, which is relatively new and focusing mostly on Tableau. The QR, by the way, is to my LinkedIn. I hope it still works. Clicks aren't working here, really. Okay. So what will we talk about today? A brief history of data models, so we understand the context. A lot about the Tableau multi-fact model, which is relatively new, how it works, how to use it, including the examples. Insights is how to use it properly, of course, and a very little about the issues and fixes, which are relatively minor and not the main reason for this presentation. And before we even start, you need to understand this is not the visual and beautiful aspect of Tableau. This is what happens behind the scenes. You won't see visits on Tableau public or that sort of thing about the data model because it doesn't. It's just behind the scenes. It's what happens underneath. All the Tableau public visualizations and all the nice dashboards and all the AI even and playing around and seeing AI prepare dashboards for you is what happens above. You could say it's the tip of the iceberg, and the data model is what's underneath. It's what's hidden under the sea. But it's a very important part. And I was at a partner webinar, a Tableau partner webinar last week. And one of the sentences that came up there right at the beginning was that the data semantics powers everything. So all the AI that everyone's talking about now is powered by data semantics. And what's data semantics? It's the data model. So that's what we're talking about now. It's very important. Let's get into it. So a brief history of data models. Data modeling was here a long time before Tableau. And the concept of BI in general and everything is based on what was called back in the day OLAP, which is online analytical processing. And basically, this is just a buzzword. What it means is the whole idea of multi-dimensional information systems. And I'm sure you already know what measures and dimensions are, so you know what multi-dimensional is. All the data that we have that has various dimensions to analyze it. So, and this was called OLAP 30 or even more years ago. And the whole idea was that you have fact tables. Back then it was still called the star schema. You could have a fact table with various measures and many dimensions in sort of a star around it, but that's just a way of displaying it. And this was called a star schema. And that's a simple implementation. And then it's, of course, developed, and there were models with multiple facts and multiple dimensions. And this is a simple model. It's actually displayed from the Microsoft Analysis Services interface. This is what a simple model would look like. Many fact tables, many dimension tables. It's a very complicated model. It looks like a very complicated model. It is a simple one, really. We're going to see it actually in Tableau in a minute. And it became more complicated. These models started evolving. And how did this evolve over time? So I think the first real software with real OLAP was Hyperion. You've probably never heard of them. They were bought and went out of business a long time ago, back in the 1990s. They had good OLAP capabilities, and then all the all sorts of competitors came in. This is more or less where I started working with OLAP in 95, 96. So there was Sub Business Objects and Click, and Microsoft. Microsoft came into the market with analysis services, which still exists to this day. Click also, of course. And various other competitors over the years with various levels of capability with OLAP. And Tableau was founded in 2003, I think. And the OLAP capabilities were very, very weak. And it's just, you could take a table and create joins, and you could have one simple model. And this has evolved over time. So in 2009 or 2010, we had blending. 2015 level of detail came in. I'm sure you already know what level of detail calculations are. This is when I started working with Tableau, and I'm really glad that I didn't have to work with it before we had the level of detail calculations. Relationships came in 2020. That allows the model to be much more powerful. And now with the multi-fact model, which came out in 2024.2, then we have a much more powerful model in Tableau. It's still not perfect. It's still not, a full OLAP capability, but it's getting very close. And that's most of what we're going to talk about today. So let's go back to Tableau. At the beginning, we had only joins. I'm sure you've seen this diagram, how you can connect a table and create joins and build your data model. Then there came the relationships, where you have different logical tables. I'm sure, Prasan, tell me if I'm wrong. People here have, of course, learned about basic data modeling, relationships, and joins, right? Yeah.
Yes.
Okay, I can see the thumbs up. Okay, so then came the relationships about 6 years ago, and you could create logical tables, and you can have the joins inside the logical tables, and this is really powerful. So you could have many-to-many relationships between the fields here, but you still have only a one-to-many relationship between tables. So each table can be connected onwards to many tables, but it can't be the opposite way around. You can't have many tables on the left connected to one table on the right. That's why I'm saying it's a one-to-many relationship between the tables. Okay, between the fields here, we know we have a flexible and many-to-many relationship. And now, today, we have a multi-fact model, otherwise called also shared dimensions, where you can have a many-to-many relationship between tables. And this is a model we'll be practicing with in a minute. So you can have many base tables. Usually they are fact tables, not always, and they can be connected to many dimension tables. So a fact table is connected to many dimensions. You can see it branching out from here, but a dimension table, this is not a good example, like dim date, can be connected to, in this case, 5 different base tables or fact tables. So it's really a many-to-many relationship between the tables, and that's an OLAP model. That's a powerful model, and we'll see what we can do with it. Okay, so how does this work? Okay, as we've seen, you have multiple base tables. Okay, the basic idea that you've already learned about this, we can have the logical and physical layers. So these are logical tables, each rectangle, and within you can still create tables with joins, like here in product, where you can see the icon. Okay. Note, any of the old models is supported. So the models, if there's only one base table, then basically it's an old standard relationship model, and it works exactly the same way. We're going to go into a demo in a second. These are the base tables. It's important to actually note this because Tableau has its syntax, its way of writing things. So these are base tables. Just a minute. And this is what's called upstream and downstream. Okay, so sometimes you'll have messages, or you want to read the documentation and understand how it works. It's important to know the direction. So these are the base tables. Upstream is towards the base table. Downstream is towards the dimension or other tables down the line. When you drag a new table in, I'm gonna actually demo all of this, but I'll go over the main points and then show it. When you drag a new table in, you always have a new base table option, so you can add it at the base, or you can relate it to an existing table. You can add relationships. You have a plus icon. You can drag the connectors. They started by calling them noodles, so we'll still call them noodles, to a new table. You can double click a table as in a regular relationship model to open the logical table and create joins. And you can, when you click on a table, you're actually highlighting the relationship, so you can see exactly what's connected to what, because sometimes it's a bit difficult to see. And I've seen models with many more relationships than this. You can also focus. This is less commonly used, but you can actually have an icon where you can collapse some of the relationships, and then you can actually focus on one table. And we'll see this in action in a minute. And with data pane, we'll get into that, but you also have some indicators when actually working with the data, what you can do or you can't do, what's related and what's related with the fields that you're using. So here you can see that I've dragged in some fields, and immediately I can see which tables of data are not related to them, which doesn't mean you can't use them, but it means something about the analysis. Okay, so let's see what we can actually see. Where is it? Okay, so you can see my Tableau desktop, right? Okay, so this is my regular multi-fact demo, based on the actually quite well-known Microsoft demo database, AdventureWorks. And you can see you have fact tables, dimension tables. They are related. The relationships are exactly the same as they work with a regular model. So if I click on a relationship, then it's highlighted in blue, and I can change the relationship, and that's exactly the same as you probably recognize from your regular work. I can take a table and drag a noodle and try to connect it to, I won't be able to connect it to another table at the moment because it's related to all. I can relate it to dim employee, but there's no field connecting them at the moment, so I won't do it. But you see how I can drag a connection from any table to any other table. And if there's something relevant, it will allow me to connect between them. Okay, same thing if I take a new table, let's say something from here. I want to add it. You see I have my new base table area where I can put it as a base table, or I can simply drop it further to the right and it will choose to which table I'm relating it. I won't do it again because I've already built the model, but you can see how it works. Okay, so dragging and dropping is very similar to the regular model. Highlighting, yeah, I can click on fact internet sales and you see all of the, if I click properly, I can, if you don't know, then this can be dragged. Okay, so when I'm on it, everything is highlighted, everything that's connected, the same for dimensions. I highlight dim promotion, and you can see it's connected to 2 fact tables. That makes life a bit easier to analyze. Sometimes the highlight works, sometimes it doesn't. Okay, dim customer is related to fact internet sales and then to all these other tables. And what I already said, you can collapse. Okay, so now this is collapsed, and then I can focus on something else. Okay, so I have very small features that help us work with the data model. But basically, it's very similar to a regular relationship model. Okay, so what can we actually do with this? Okay, what's the difference between this and just one flat table or a regular relationship? Not much, but except that you have these connections between the tables that enable a much more flexible analysis. So for instance, let's look at this AdventureWorks model. I'm going to open, if I manage to move a Google Meet stuff, I'm going to open a worksheet. Okay. And let's say I want the date. Okay, I'm going to want to see my data over time. And I have different fact tables. So I can take reseller sales amount. This is my revenue from my shops. But I can also take my internet sales amount, which is a totally different fact table. This is my revenue from online sales. And I can analyze them using a common dimension without any problem. Instant analysis. Let's take another common dimension. They also have a product dimension, which is common to them. So I'll take my product subcategory and put it here. Okay, well, actually, probably better to put the measure names up here. Okay, so for every product category, I can see values from different fact tables together. I'm analyzing by the same dimensions. And this is for basics of analysis that you have different facts. Let's take another one, fact sales quota. I have a quota. Okay, did I meet my quota or didn't I? Now, this is expanded to all the, okay, it's not, the quota is not by subcategory. Okay, and here you can see what happens when something is not connected. You have the icon here of a relationship, and it says, as you can see, there's a slash on it. It's not related, product subcategory, because there isn't a quota by subcategory, but there is a quota by category. So I'm going to replace this. I think there is. No, there isn't. Okay, my mistake. Okay, let's just drag the field up. But now I have my quota. Okay, so this is my sales quota, and I can compare the sum of these two, if I want to my quota, my target. Okay, my quota is my target, and I don't even remember to which this is connected. Let's go back. That's my memory. Sales quota. It's the employee. And the employee is connected to reseller sales. Okay. Not interested in the employee at the moment. And you can see I'm analyzing data from different fact tables. That's the basics of this. Why do we need it? This is a good example, but there are better examples, and I'm going to show you a really nice one. We'll go back to the data source here, and I don't have any data here, but I have the model. Okay, and I'm going to talk to you about this model. This comes from, this is a real situation with a customer of mine, which is a public transport company. So basically they have buses, and the buses travel all these public transport routes, and there's tons of data. And this is the model, the ideal model that we don't have yet there, because they're working. They have so many dashboards on the old model when we didn't have multi-fact that we can't really change it. It's going to take time, but this is what the ideal model would look like. So your main dimension is a bus, okay, and each bus has multiple fact tables. There are a few more, but these are the important ones. So the trips, every time a bus takes a trip, starts at point A and finishes at point B, it's logged as a trip. Maintenance, bus goes to the garage, gets some maintenance. Of course, it costs money. What did we fix? That sort of thing. So you have fact bus maintenance. Speedometer, how many miles or kilometers were logged for the bus each day? That's another fact table. One record per bus per day. Fuel, every time the bus fuels up. Now we have the electric one, so there's a different fact table for that data as well. Every time you fuel the bus, how much did you fuel? Events. Events are accidents, customer complaints, inspections by inspectors who go on the bus and check that everything's in order. So you have events. All of these together need to be connected to bus. Each one is of a different granularity. You can't union them. You can't, barely have common dimensions apart from the bus and the date. Date is at a different granularity, of course. This fuel is whenever it happens. Kilometers is once a day. Maintenance could be once a month. Trips, you have 20 or 30 a day. This is another fact table that's not actually connected to bus. Work hours for the drivers. Okay, but the drivers also are connected to the bus trips. There's a great calculation there, by the way. That's the driver utilization. Driver hours in the bus trips divided by the hours they are paid. Okay, if that's too low, then they're not cost effective. If it's too high, they're working the drivers too hard because they need to rest as well. So lots of information here. Bus trips goes to bus tickets. Every passenger pays for a ticket. Passenger counts. Every passenger is counted by the, there's, cameras on the doors. There's a beautiful measure there, but bus tickets divided by passenger counts. How many people didn't pay for the ride, which is really important. Tells you when and where to send the inspectors. Lots of data here, and the multi-fact model is really great for this. Before the multi-fact model, we're talking about 6 or 7 data sources. Some fact tables appear in 4 or 5 of those. So for fact bus trips, which we're talking about tens of millions of records, is actually duplicated in quite a few different data sources because we didn't have a multi-fact option. Okay, because it's connected to nearly everything here, and every different analysis needs a different granularity, so you're building a different data model. Okay, and that's the power of a multi-factor model. Maybe we have a pause here if anyone has any questions or something. No? Okay. You're still with me at least?
Yes.
Yeah, okay. And I always have these presentations, you're talking to the screen, and it's already happened to me once that I got disconnected and I was talking to an empty screen for 5 minutes. Okay, so these are examples, of course. And we'll go into a few insights. I'm going to actually display these insights in a minute. Okay, so you have in the PowerPoint, which I'll send over later on, you can actually see the same data sources that I demoed. So let's talk about some insights from our experience with multi-factor models. And let's see. So first, the base table can be more than just one table. So you can actually use relationships to link parent and child tables and dimensions from either of them. So I can't actually show you some of my customer examples, but I can show a simple demo. If you look at just show this. This isn't a multi-fact yet, but it could be. This is what I call a parent-child relationship with fact tables. So service orders is a parent table. Every someone calls in an order, I have an issue, a problem, it's called a service order. Service orders log in this case is a child table. It has several records, several rows for each order. So it's related, see one-to-many, order number on the left, and order number on the right, but there are several records for each one. These two together can also serve as sort of a base table or a fact table. And that's a very common use of relationships in Tableau. It's something that in the past, before relationships, we would have to join them. And then every record here is multiplied by its children here. And there are other examples, of course. You could have invoices and invoice lines. What are the other examples that I had here? Help desk calls and calls log, that's this one. Patient, I work with healthcare a lot. So patient visits, and they have two child tables, one for treatments and one for medications. So you could, the doctor would prescribe several treatments or additional visits or something for a patient, and also several different medications. So that's a child table. All of these could be sort of part of a base table. It's expanding the base table, and that's a very common use here. So here, if I connect to this actual model, so you can try and let's just filter by the dates. So we don't have too many. There aren't very many, but it doesn't matter. Say December 2022, and I can put all the order numbers, and then I'll give you the log timestamp here. You see, each one of them has a different different number of log entries. So that's a child table, but both of them are facts. Okay, and you can connect them onwards to different dimensions. So that's a parent-child relationship, and it's important to take into account that you can use it. I think it's not used enough in Tableau. You can relate at different levels. So this is an academic, small academic model we're using. But if you see here, okay, you can see two different relationship paths. So course progress is a fact table that is related to a lesson. Okay, that you take a course, you have several lessons in the course. So you measure your progress by which lessons you completed. That's the progress. But you enroll in the course itself, the whole course. So relationships can actually be at different levels. You can see how the path goes through the course lesson here, but directly to course details here. Okay, so that's an example of how you can relate to different levels. Another example would be the date dimension. Okay, now date dimension has two aspects. First, you need a date dimension. Until now in Tableau, you didn't need a date dimension. Okay, because Tableau takes care of all the hierarchies, you know that. You can use any date in any way that you want. And you didn't have common dimensions for different tables. But in a multi-fact model, and this is one big difference, if you want to use dates to analyze your data as a dimension, you need to create a date dimension. You need a date table. Okay, if we go back to my my model here again, go back to the data source and to AdventureWorks, you see that I have this date table up here. It's a very simple table. Let's have a look at it. Edit custom SQL query. Okay, I just have two fields, date key, and the alternate key is the actual dates. Date key is a number from dim date. So I just need the dates, but I need some sort of common table in order to link the different dates from the different fact tables. Now, what's important here is also to note that you can only link one date field from each table to dim date, of course. You can't link several fields from the same table to the same common date. Okay, so just be aware of that. And you can relate at any level. The relationship doesn't have to be at, if this is a table of dates, you don't have to relate them at the actual date level. You can relate at the monthly level, at the yearly level. So if we go back here and we look at the quota, okay, let's look at the quota relationship to date, and notice that, let's expand this a bit. We are at the month level. We're using the date trunk function, and we're relating, okay, at the monthly level. So the quota is at the monthly level, and of course, different facts could be a different level. Let's see, the inventory is also a date. Okay, sometimes inventory would be at the monthly level or weekly or any other level that you need. So you can relate to different levels. And I think I also have something related to product at the category level. Here, survey response to product. Even that is not at the product level. I'm trying to click it. Sometimes it's difficult to select the relationships here. Okay, and you see the relationship is not at the product level because there's a hierarchy here as well. There's a relationship at the product subcategory level. Okay, more insights. Row level security. Anything we could do with row level security in the past can be done with multi-fact models. Have you learned how to implement row level security?
It's at least not something we've talked about yet
Okay.
in the class.
So it's okay. So it's a bit advanced, and I'm not going to go into it too much here. So you can look at the slide and understand. But row level security, I'll just talk about it a minute. Basically means every user sees their own data. Okay, so and we implement it by having some sort of security table that says which user can see what. Now, if I go, I have a row level security table here. This is actually an Excel spreadsheet. Okay, I created, let's see if it shows me the data. Okay, I'm actually filtered by security, so I'm only seeing what user A can see. But I have several users here, and I'm now going to switch a parameter. I'll just go to the RLS sheet, and you can see I have, usually it would be the logged in user, but here, because I'm not logging into anywhere, I'm just using a parameter. Let's say I switch to user C, and you see the data filters automatically. That's row level security. Every user sees only the product categories that he has permissions for. Okay, user D has only clothing, and user B has only bikes. And E has bikes and components. A has everything. Okay, so that's an implementation of row level security, but it works just as it works in old Tableau models. And if you learn about it, you'll see it. You just link to the correct dimension, and this actually in real life scenarios, of course, uses the logged in users. So if you logged into Tableau server or cloud, it identifies who you are, not user A, B, C, or D, but your real username. And of course, the real username is what appears in this table. Okay, so you can implement row level security without multiplying data or anything. And if we go and summarize a bit, let's see what it means. What are the differences? Because you've learned about joins and relationships, but let's see what we have as a summary. When to use joins and when to use relationships, and when to go to a multi-fact. So the main advantages of joins in Tableau is that joins, and we're talking about extracts most of the time, not going live to the database. Joins create a flat table, one big table with all the data. It has an advantage of performance. It will work faster. Okay, but you have disadvantages. You have a possibility of multiplying your data if you do an incorrect join. Retrieval could be slow because you're joining the database, you're bringing more data. So you're dependent both on query performance in the database and on the transfer. And I work in really large environments. So we have cases where we have hundreds of millions of records. This makes a difference. Uses more storage, that's also connected. And row level security is difficult. With relationships, you have a disadvantage that you could get a performance issue on complex queries, but usually not. Advantage of flexibility, of less storage, of implementing row level security. Flexibility is infinite. You can create so much stuff. I can teach that for a week, not for an hour, so we won't go too much into it. We're talking mostly about the multi-fact model. And with multi-fact, you simply have more flexibility. With a disadvantage, which we'll talk about for a few minutes later, there are functional limitations. We've had showstoppers with multi-fact, where some functionality, some sort of calculation won't work, and then we have an issue. Okay, I'm going to talk a bit about the performance, and I'll give you an example. Okay, this is a real life scenario. I can't show you the actual data sources, but this is something from healthcare, where we have, let's say we have a dimension called a sector, and all the analysis are always on one of the sectors, okay? And you have 4 identical or almost identical fact tables, okay? One for each sector. Now, you could union them, and that's what we've been doing until now, and analyze them. Now, what happens here? Every time you filter, every time you look at a worksheet, you're analyzing over 400 million rows. And this is one of the things you have to understand about relationships. And if you've learned about them, you should probably know. When you query data in a relationship model, Tableau queries only the tables that are actually in use. Okay, so here we're always using a fact table. We're always querying a table of 400 and something million records. That affects performance. We created a multi-fact model, which is based on 4, again, almost identical fact tables. Nearly all the dimensions are common to all of them. But because the analysis is always filtered by this sector dimension, which goes to one of them, so when someone is analyzing one of these, this table isn't used at all. Okay, so performance is much faster because we're looking at smaller tables. When someone analyzes the large table, okay, they have slower performance, but they will have that anyway. It's still quite good performance, by the way, but we're not affecting the other ones as well at the same time. And that's, again, that's something you should think about. I don't know if any of you work with these quantities of data, but I do it regularly, and we take these things into account. So again, that's a model where I'm going to show where you actually take into account how relationships work and try playing around with different models. I'm going to actually show this just so you where were we? Sheet 8. So you look here, and I don't know if you've worked with this already, but you have this option here, View Data Model. Okay, so whenever you have a worksheet, you can see the data model, but you can also use this, Hide Unused Tables, and understand how many tables are actually used in this worksheet. And this is great for seeing how complicated the analysis is. When you're touching the large, slow performance tables and when you aren't. So now we try to use this a lot. Okay, it tells you where you have problems. In relationships, as you use more tables, you could create performance issues. So whenever you create a worksheet, use the View Data Model, have a look. The less tables you have, something like this, works really fast. You start connecting this to another table and then to another one and another dimension and more, it starts getting slower. So you can easily monitor this and know what's happening. Okay, so when do we use joins? We talked about why and what advantages they have. And my recommendations, all joins that you actually use within a logical table should be many to one or one to one. So they never multiply your records. Always you're connecting to a primary, a unique key on the right side. And basically only to join to dimensions that are not shared with other fact tables. Or to a hierarchy of dimensions like here, where product has a parent, which is subcategory, and that has a parent with category, and you want to lump them together in one dimension. Okay, but for fact tables, join to dimensions that are not shared with other fact tables. If we go back to our model here, we can see this. Okay, so if this would be an example, let's say dim reseller, it's connected only to fact reseller sales, so we can actually join inside here if we want. Okay, don't always have to. We can use it like this, but it could be joined inside because there's no other relationship that's used. Okay. I have a link here. Again, you'll get this to what is allowed and what is not. It's really complicated. It's a bit difficult to understand in a multi-fact model. I'm not going into detail here. Some things are allowed, some things are not allowed, like this, which looks sort of a circular join, but this also looks like a circular join. So why is this allowed and not this? Read about it and try to understand it. So you can, something like this is not allowed, nested shared tables. Any tables downstream from a shared table, downstream this way, can only have one incoming relationship. So if there's two relationships here, you can't have something else here. So I can show you, and not everything has a solution. I can show it here. We have a good example with the buses. Okay, these three fact tables, which are basically child tables of bus trip, have a common dimension, dim station. Okay, every ticket, every stop, every passenger count is linked to dim station. We can't create this connection. Okay, you can't link these three to the same dimension. That's a limitation. Same here, we have so we try to change it around. Okay, put these as the base tables, call the bus trip sort of a dimension. Okay, and then you can connect them, and you can connect them to station, but then you can't connect the bus trip to dim date, which is a common date dimension for everything. Okay, so you get stuck with that. So not everything has a solution. Complicated models, you start playing around, looking for complicated solutions. Okay, you can create cross joins, which is probably also haven't learned about that. This is one of my favorite techniques. Search for expander tables. I have a link here for someone's blog, I think, where you can learn about it. They can be used in multi-fact models the same as in a regular relationship model. So it's worth looking it up. Okay, and before we go to the issues and fixes, I'll go to another model that I wanted to show, just a quick example. When I talk a lot, it can take a long time. Can we go over time a bit further than the hour, Prasan?
Yeah, that's fine.
Yeah, okay. So I took a standard Salesforce model, Salesforce data. Okay, I'm not going to show you the data, but I'm going to show two ways to model this. And just so you understand how this modeling can be really interesting and challenging and can solve problems in different ways. So Salesforce works in a very, very structured way. Everything is connected to account. Okay, account is a customer or a supplier, it could be, but a company usually. Okay, everything is connected to account. So in this example, I have cases, customer support requests, sort of, which is a fact table, and account is a dimension. Opportunities to sell something, so it's all the sales and marketing. And again, account is a dimension of opportunity. Task is could be tasks to do usually. Meetings, sales meetings, that sort of thing. That's also connected to account. And there are a few other common dimensions like contact, which is people, owner, which is who owns the case, that's the employee who's in charge of it. Opportunity has a child table, opportunity line items. You could say, call it customer orders and order lines, order products. Okay, and this is a standard model. Note for date dimension. There is no date dimension in Salesforce. This is an Excel table, because if I create a multi-fact model on Salesforce data, it's not a data warehouse. There's no date dimension. I need to bring in something external. But I can also build it a different way. This isn't a multi-fact. This is a simple relationship model. I'm saying account is my base table. Every account has cases, contacts, opportunities, opportunity line items. I could put in, I can drag in tasks as well. Let's bring in the tasks. Where was it? Okay, I can link task to account. And ID. And account ID. Okay, and this is a relationship model where I don't have a common date dimension, but otherwise I can probably do almost everything that I would do in the other model. So there are different ways of modeling, different ways of doing it. There are limitations here and there are limitations in the other one. Okay, and every combination of fact tables, dimension tables, and everything that you have with a database could, it's creating my extract because I added a table. Okay, so every combination of tables and analysis can be modeled in different ways, and you have to take this into account. And again, I could teach this for a week, and we actually do have courses for this stuff, but let's keep it at that. A few words about the issues. The multi-fact model came out almost 2 years ago, in version 2024.2. There were lots of bugs at the beginning. Most of them will be fixed. There are a few issues. Some of them are, I call them bugs, they call them features, limitations. I have listed them here so you know what you can't do with examples. So any level of, for instance, the level of detail that references measures from different tables causes an error. So, and I'll just move this. Okay, so if I do something as simple as fixed on a product subcategory, take my internet sales amount plus reseller sales amount. It's a very simple level of detail calculation, which is actually logical. I would want to do something like this. It raises an error. Okay, there's no workaround, there's no solution, but it's acknowledged. They know that it's a limitation. Tableau, and it maybe they were discussing that maybe they would change the architecture in a certain way so that it would work, because this is a limitation. You simply can't do this. Okay, so that's an issue. Measure filters with calculations spanning more than one factory, you get an error. Actually, it's doesn't filter properly, or you get an error. So there's a problem with that. There are switching fields is a well-known issue. I don't know if you've learned about this trick where you can use a parameter to switch between fields. So when you switch measures in a multi-fact model, there's no issue. When you try to switch dimensions, you get an error. Okay, if you get this row-level calculations can't reference fields with different upstream base tables, that's a problem. That's a real limitation for scenarios where dimension switching is used. So again, you can't do everything, but you can do a lot. I can actually demo those things, but we're out of time, so I'll skip that. And if anyone has any questions, then I'll stop sharing and see you again. And
Hello.
and I did this in well, I did a short version of this in 30 minutes at DataFab.
Yeah. So it's a bit nicer today to when it
Yes,
for me.
I went a bit deeper, and but still, I could teach a whole course on this, of course.
Yeah, it's quite technical. So that's for people who are fairly new or newish to these type of data models. It's a lot to grasp as well, because the any question anybody has for you would be, it depends, right? Because it depends on what is the use case, or you don't need to have that huge model necessarily, because you, as you show, you could when you, especially when you looked at view data model and see, well, we're only using these 3 tables, so why do we build the whole model? And I
But
have some,
again, sometimes you need it, and I've seen, and I have to tell all the people here, you don't have to be an expert to work with these models. I have people, customers that I'm working with, where the analyst on the other side who's actually developing, I'm just a consultant. They learn quickly. They have someone who's, if I have someone who's helping, someone like me, who knows a bit more, who's helping them, they understand the multi-fact model, they start playing around, they start solving problems by themselves, and they make progress really fast, and they become experts really quickly, and they don't need my help for everything. They learn a lot of things by themselves, and I've reached situations where I taught the basics, I explained a bit, and a couple of months later, they're coming to ask me a question, and they show me the data source model, and I look at it and I say, wow, you did that without me. Okay, so I'm sure all of you can do the same in a business scenario when you need it. And they did it because they needed it, not because that was the solution. And I have really complicated use cases for multi-fact models.
yeah, for those of you who are still here, do you have any questions or any comments or feedback to Dan?
Hi, Dan. Thanks so much for sharing today. Can I have a quick questions related to the relationship? As you share that it has more flexibility rather than choice. So in which case we use choice and in which case we use relationship?
Okay, so I had a slide about that, but I use joins again in 2 cases. Joins are basically only for dimensions. If a table has to, let's say you have a fact measure table with a customer ID, and you need the customer information from the customer table, that's a join to dimension. Okay, so if I'm using the customer dimension only for that table, then I would use a join. Again, if I'm in a multi-fact model and I have several fact tables and more than one of them needs the customer table, then I already need a customer as a separate logical table, so I can join 2 different tables to it. Okay, and the other example I showed there was with a hierarchy. So you have product and product parent, you could say, a product subcategory it's called, and there's a product category which is also a parent. So it's just you could say a string of tables in a hierarchy. Then also I would use a join. There's no need for a relationship in that case.
So you mean that for the subcategory we can use the relationship? Is that correct?
Yes, yeah. For if it's let's say a parent dimension, let's say you have a dimension, a common dimension, so you need a separate table customer, but then customer is also linked to customer type, okay, which is another small table. You don't need a relationship to customer type. It's just a lookup sort of, just a dimension of a customer. So in that case, you can use a join.
Great. And another thing is that when I see in the data modeling, they are, it seems like static tables. So in case of we have the table which is uploaded in the Tableau server, is it possible for us to create a relationship between multiple live table?
Yeah, yes. A data source in Tableau can be live or extract, even if it's a multi-fact model.
Mm.
Okay, so you create it in Tableau desktop. You can actually create it on the server, but a data source as a whole can be either extract or live. If it's live and a multi-fact model can be live, then every query will know how to connect and create joins or query in a different way for different tables. Okay, it can be live.
Do you have any example? Because I had this issue before when I use SQL to create a table and upload on the Tableau server. So it turned out to be the live data set, but then I want to connect this data set with another live table as well, but it doesn't show any function to create a relationship. It's only show the relationship when I connect with the Excel file or the CSV file only.
Yeah, but is it because if you have a published data source with a table and another published data source with another table, you can't do anything with those yet. And you can do that to create joins in Tableau Prep, but you can't create joins, or then you have to use blend, which I guess you don't want to do.
No, I think you need to you need to show me the exact use case. I mean, you can contact me, and if you need some help, private help, a short session, and I'll be glad to help.
Okay, that's great. Thanks so much.
And we have a question for Shrikant in here. Do you have to work closely with the data engineering teams when going through modeling?
Not necessarily, because and it depends. So some of my customers, they already have a data warehouse. Okay, and all the tables are organized there. And so let's say my largest customer nowadays, they're a really large healthcare provider, and they're migrating from an old system. So they're building everything new in Tableau. We almost don't work with data engineering. The data warehouse is organized. It's nice. It's just building stuff, building the models in Tableau, and the data is already there. But if you're building a new system, a totally new system, you come to a customer who has various applications, Salesforce, for example, some sort of HR application, accounting, and different data from each of them. Sometimes, yes, data engineering is the team who has to bring all this into a database, into a data warehouse to organize it. And that's what I've been doing for my whole career at the back end. Tableau is the front end, but that's the back end. And only after that, usually do you work with Tableau and create a data model. Yeah, but it very much depends on the complexity of the data. We have small customers where we connect directly to whatever they have, even if it's a bit of a mess, because it's not worth it creating a whole data warehouse. And that's a whole new field, a different field of BI. And we have customers where we look and say, okay, we don't do anything for you, organize it and create a data warehouse. And that's a separate project. Okay, so it depends. As I say, all the answers to all the questions are, it depends.
Yeah, that's the challenge, right? And also love when the client is, well, I need all my tables, all my dimensions and measures, because I'm always going to be, I might need it someday. And then, in real life they only need 10% of it or something, right? Or
So with this large customer, well, you can't, I mean, they have hundreds of tables in their data warehouse. No, we're actually taking project by project, bringing in the tables necessary for that specific subject, that data model. And they will have in the end, I think they're going to have hundreds of data sources, but that's down the road.
you won't have one ring to rule them all, or one data set.
No, there's no way to create a data source on more than, I mean, technically you can, but no one creates data sources with more than 5 or 6 fact tables at least.
Yeah. Any final questions from you guys? Of course, this is recorded, and your presentation, that's on your Tableau public profile.
I'll send the presentation PDF to you, and you can send it to everyone.
Cool.
Okay.
Thank you. Thank you for taking the time.
You're welcome.
I'm really happy to see it like the more extended version, even though, as you said, it could be 2 days, but 1 hour, 5-10 minutes is better than 30 minutes, as we saw, or I saw it last time.
Yeah, but last time it was defined as an advanced session. It's I tried to bring in a bit more intermediate level details.
So thank you for all who joined. Prasan, he's the key master of sending the invites. We already have. We're not sure if we're going to get Adam Mikko next week or if that's going to be postponed, but we already have at least one session booked now in April, where we're going to be focusing on Tableau prep. So prepping data before we even put it into Tableau, and we might not even need those multi-fact tables or anything. We just prep it before we put it into Tableau. So we'll see.
We could have half an hour of arguing about that.
Yeah, I know.
There's no way one big flat table can replace a good multi-fact model.
No, I totally agree.
What I would really like is for Tableau Prep to be able to create a relationship model.
Yeah, and that's something I hope, which is on the roadmap for a few first.
Yeah.
Okay, have a nice rest of the day or night or whatever time it is, because we have people from all over the world as usual in here. Nice seeing you again, Dan, and we see each other hopefully next week for the rest of us.
Thank you.
Thank you.
Okay.
Bye, welcome. Bye.
Thank you.
Bye.